Alright, our third video of the year, here we go, 1.3 addition and subtraction of algebraic expressions. Now one thing I want to remind you is the videos are not interactive at all. At least my videos aren't. So I'm going to be talking at you, talking, and if you get any questions, I want you to write them down right here. This is the space for your questions, and in fact, you're going to need to come up, I want you to bring to class at least one question. If you've got no questions, that means you're not thinking. So come up with questions, I want to hear them, write them down right there. Also, I'm going to make sure that you're listening, so I'm going to drop some information. For example, the fact that I've got, at the time of this recording, I've got a wife and 2 kids. Their names are Elliot and Anna. So I want you to write Elliot and Anna right here, the name of my 2 kids. That's what we do for an audio check. Alright, so addition and subtraction of algebraic expressions. We got some vocabulary to go over. Now, most of the algebraic expressions that we're going to be talking about are what's called polynomials. And poly just means many, many nomials. So here is an example. Here, if you have one term, that's what's called a monomial. So, for example, 9a is a monomial, and negative 9 to the negative 9y to the third is another monomial. There's only one term. Here you've got 2 terms, and they're separated by addition, or sometimes subtraction. 2 terms, they're called binomials, 3x to the 4th plus y. There's 2 of them, 2 terms. Here there's 3 terms, 1, 2, 3. That means it's a trinomial. 4 terms would be 1, 2, 3, 4, quadrinomial. Polynomial is just a group, these are all polynomials, because they could have many terms. Now, the difference between the horizontal lines, the difference between the degree is your exponent. Here, there's an exponent, the highest exponent is 2, so therefore we call it a quadratic expression. 3 cubic. 4, now I know I don't see a 4 here, but 2 plus 2 is 4. So there's 4 total variables being multiplied by each other. So therefore the degree is 4. We call it a quartic monomial. This is a quartic binomial because the highest degree is 4. The degree here is 3. The degree here is 3. The highest degree, so let's count the terms. 1, 2, 3, 4 terms. That means it's a quadrinomial. And the highest degree of any of these is 3. M to the third, n to the third, 1, 2, 3. 1 plus 2 plus 3 is 3. All these 3 terms all have a degree of 3. So therefore it's cubic. It's a cubic quadrinomial. Down here I don't see any exponents, but you can always write one in. This is 9a to the 1st power, therefore it's a linear monomial, a linear binomial, a linear trinomial, a linear quadrinomial. And if you have any numbers that have no variables at all, then that's a degree of 0, because there are 0 variables there. It's a constant number, a constant monomial. So, if you wanted to find the degree of each term and the degree of the polynomial, then you start off with the terms themselves. The degree of this term is 8. Let me do that in black. 8. The degree of this term is 6. The degree of this term is 4, the degree of this term is 9, the degree of this term is 0. So the highest degree of each of the terms is the degree of the polynomial. The polynomial therefore has a degree of 9. Let's do that again in the next problem. So the degrees here are 4, 3 plus 1 is 4, 2 plus 3 is 5, 5 plus 1 is 6, and there's no variables here, so I'm just going to write 0. So those are the degrees of all the terms, and the highest term is the degree of the polynomial, which is 6. This polynomial has a degree of 6. Combine the similar terms. What do we mean by similar? Similar just means they have the same exact variables and exponents on those variables. So, let me find the similar terms. We've got x to the third, y squared, x to the third y squared. That's different from x squared y to the third. So that means we can combine the first two. 5 plus 4 is 9, x to the third y squared, minus 2x squared y to the third. That's your answer. Let's circle it. Moving right along. Next problem. You can see here we've got xy squared. Do I see any other xy squareds? Xy squared. And then we've got x squared y, x squared y. That means I'm going to combine this 3 and this 4, and this negative 4, and this positive 2. I'm going to have 3 plus 4 is 7 xy squared. Negative 4 plus positive 2 is negative 2 x squared y. Moving to the next problem. We have x to the fourth y, this is the square root of y, and x to the fourth square root of y. So that means 5 minus 2 is 3x to the fourth square roots of y, plus 2. We're going to add these together. So let's find the like terms. We've got x to the third, x to the third. We've got x squared, x squared. We've got x, x, and we've got the constant term, the constant term. So let's add. We've got 3x to the third plus negative 7, that would be negative 4x to the third. 4 plus negative 2 is 2x squared. Negative 7 plus positive 3 is negative 4. X. And negative 2 plus positive 1/2. Negative 2 plus, it'd be the same thing as negative 2 plus positive 0.5. That's going to be negative 1.5. Done. Next problem. So we've got p squared q to the fourth, and I don't see any others. Then we've got p squared q squared, p squared q squared, and I don't see any q's, and I don't see any other constants. Not a whole lot of like terms here, only one to combine. That's this one. We have to write out all the other terms. So that's 5p squared q to the fourth plus, is negative 2 plus 3 is 1. 1p squared q squared minus 3q plus negative 6 pq squared plus 5. And that's it. Find two equivalent expressions for the opposite of the expression. So what they mean by this is you can take this whole thing and you can just say the opposite of this would be negative 5x squared t squared minus 4x y squared t minus 3xt plus 6x minus 5. You can just put all that in parentheses and make it negative out front. However, if you want to kind of distribute the negative towards all the terms, you have to change their signs. negative 5x squared t squared plus x y squared t plus 3x t minus 6x plus 5. Those are the two equivalent expressions for the opposite of what they gave you. I'm going to let you do that here. Same thing. I want you to fill out negative, and then, so this would be negative 3x squared y. I want you to fill the rest. And then this would be positive 3x squared y. I want you to fill in these here. You do it. Now, why is all that important? It's because when you subtract expressions, like in number 10, you need to first find the opposite of the subtrahend, the second number that you are subtracting. So I'm going to rewrite this. We're going to distribute this here. The subtraction symbol will change all the signs. This will become plus 3xy to the fourth minus 2xy squared plus 2y minus 4. That's what happens when you subtract. You have to change the sign of the second symbol. Then this all just gets recopied. 5xy to the fourth minus 7xy squared plus 4x squared minus 3. Now let's find some like terms. Let's see, x y to the fourth, x y to the fourth, xy squared, xy squared, x squared. I don't see any others. There is a y, and there's also a constant term that we have to combine. So we have to combine these, and these, and these. So 5 plus 3 is 8. You see what I did there? That's an 8. 8xy to the fourth. Then we've got negative 7 minus 2 is negative 9, minus 9xy squared plus 4x squared plus 2y, and then minus 3 minus 4 is minus 7. Number 11. The first thing I want to do for number 11 is change the signs. So this is going to be minus 2x squared y minus 2x cubed y squared plus 5x squared y cubed plus 5y. Recopying all the rest, it's just 5x squared y minus 7x cubed y squared minus x squared y squared plus 4y. Now, do we have any like terms? Yes. X squared y, x squared y. X cubed y squared, x cubed y squared. X squared y squared. I don't see the same thing over here. It's y cubed, so therefore they're different terms. Alright, let's combine them. we're going to have 5 minus 2 is 3, x squared y. Negative 7 minus 2 is negative 9, x cubed, y squared. We still have the blue x squared, y squared. We still have the red 5x squared, y cubed. And 4y plus 5y is 9y. And that's it, we're done. See you in class. Make sure you bring your questions and make sure you start begin assignment 1C. Just do the first problem if you can. If you can do more, that's great, but at least do the first problem.